Welcome back. Today we're talking about hexagonal architecture. It's the gold standard of modern software design. By isolating your core business logic from the outside world using ports and adapters, you gain ultimate testability and framework independence. It sounds perfect, right? But there is a dark side to this elegant pattern. In the relentless pursuit of architectural purity, many engineering teams accidentally build a performance bottleneck. We call this the hexagonal architecture scam. It's what happens when the very abstractions designed to protect your application end up suffocating its throughput. Let's unpack exactly how clean code can kill your performance and what you should do instead. In a traditional hexagonal setup, your application is divided into strict layers. At the center is your pure domain model. Wrapping it are ports, interfaces that dictate how the outside world communicates with the core. Finally, adapters implement these ports to handle HTTP requests or external APIs. Visually, it is beautiful. A request comes in, translates through the inbound adapter, executes in the pure domain, and reaches out via an outbound adapter. But every single one of those boundaries represents a physical boundary in memory and execution time. You are no longer just executing logic, you are traversing a gauntlet of abstractions. Let's look at the first hidden cost: interface dispatch. In languages like Java, C# or Go, calling a method directly on a concrete class is blazing fast. The CPU can easily inline the code. But hexagonal architecture demands interfaces for everything. This means your application relies heavily on dynamic or virtual method dispatch at runtime. The CPU can't easily predict which implementation will execute, defeating instruction caches and branch predictors. For a single request, this nanosecond penalty is invisible, but scale that to tens of thousands of requests per second, and suddenly your CPU is spending a significant fraction of its cycles just figuring out which code to run. The most devastating performance killer is the object mapping tax. To keep the domain pure, hexagonal architecture requires you to isolate its models. This means when an HTTP request arrives, its JSON is deserialized into a data transfer object. That DTO is mapped into a domain entity. When saving to the database, that domain entity is mapped again into a database entity. That is 3 distinct objects created in memory for a single lifecycle. Multiply this by thousands of concurrent users, and you create an avalanche of short-lived objects. Your garbage collector goes into overdrive, pausing application threads, spiking latency, and consuming massive amounts of RAM. Abstraction also destroys data locality and query efficiency. Because your domain is blissfully unaware of the database, it often requests data in a mathematically pure but mechanically disastrous way. Instead of leveraging optimized SQL joins or specific indexes, your repository pattern might pull entire object graphs into memory just to update a single Boolean flag. Or worse, it triggers the dreaded N+1 query problem behind a clean-looking interface. The adapter has to respect the domain's ignorant contract, stripping away the incredible power of your modern relational database engine just to satisfy a theoretical design principle. This brings us to the core of the scam. The truth is, 80% of most applications are just simple CRUD operations: create, read, update, delete. Applying hexagonal architecture to a simple data fetching endpoint is like building a multi-lane highway interchange for a quiet suburban driveway. You are paying all the architectural taxes, the mapping, the interfaces, the garbage collection pressure, for zero benefit. The domain logic you are protecting doesn't actually exist. It's just moving data from point A to point B. By treating every endpoint as a complex domain problem, you drastically reduce your system's baseline performance. So, how do we fix this without descending into spaghetti code? The answer is pragmatic isolation, often implemented via Command Query Responsibility Segregation, or CQRS. For complex business logic, like processing a payment or calculating taxes, keep your rich domain model. Build the Hexagon. But for simple reads and queries, bypass the domain entirely. Let your API controller talk directly to a thin data access layer that executes optimized SQL and returns exactly the JSON structure the client needs. No interfaces, no domain mapping, just pure, unadulterated performance. Ultimately, architecture is about trade-offs. Clean code shouldn't mean slow code. By adopting a vertical slice architecture, you can choose the right pattern for each specific feature. High complexity writes get the full port and adapter treatment. High volume reads get direct, low-level data access. Stop blindly applying the same heavy abstraction to every problem. Respect your hardware, leverage your database, and let the complexity of the feature dictate the depth of the architecture. Thanks for watching, and remember to measure your performance before you abstract it away.